Welcome you all. We are going to tell about the interior of the Earth. Interior of the Earth, as the name indicates, is the central part under the Earth crust. The direct observations of the Earth are limited to its outermost skins. From the observations, wells, mines, and bore wells, we know that there is downward increase in temperature and pressure. The average density of the Earth is 5.52. Rocks found on the surface of the Earth have an average density of 2.7, which is less than half the value of the entire Earth. Hence, the interior of the Earth must consist of material which is heavier than the rocks with which we are familiar. The study of the earthquake is called seismology. During earthquake, elastic waves are propagated from focus in all the directions. The seismic waves are classified into primary, secondary, and long waves. Primary waves abbreviated as P, secondary waves abbreviated as S, and long waves by letter L. These waves travel differently in different rocks. For our purpose, primary and secondary waves are important as only they penetrate the earth. The P waves and L waves are called body waves. L wave travel found to travel on only on the surface of the earth. Hence, L waves are called as surface waves. It is found that from the seismic data that P waves which travels approximately at the rate of 6 to 7 km per second in the outer layer of the earth. Suddenly it increases its velocity to 8 km per second as soon as it touches the boundary of the mantle. Therefore, the P waves processed with an increasing velocity and attains the maximum of 13.64 km per second. At 2900 km level, the velocity of P waves then suddenly falls to 8 km per second as it has entered altogether a new medium. This is the most important feature of the Earth's crust and Earth's interior. It indicates clearly that the medium below 2900 km per second level for a length of 3471 km consists altogether of different substances. It has been named as the core of the earth. The P waves provides other valuable information of the core. As soon as it enters the core, its velocity shows some rise up to 2176 km per second before coming constant. The S waves, on the other hand, is altogether deflected at 2900 km level, providing positive evidence of a liquid medium at that depth. There are two different discontinuities. Moravec or Mohs discontinuity and Gutenberg or Waldbaum discontinuity. Mating different zones within the earth, earthquake waves undergo refraction and partial or complete reflection. Refraction abruptly changes the direction of propagation. Reflection sends part of the wave energy back to the surface. Another distinct feature of seismic wave travel within the earth is that at epicentral distance of 105 degree to 142 degree of arc, both P and S waves are blackened out. It appears that the S waves cannot penetrate the core and the P waves are doubly reflected inward at the boundaries. The net result is blind or a zero zone about 4,300 km wide. These boundaries of these different depth zones based primarily on seismic velocity changes are called discontinuities. These changes may be due to change in composition, change in the state, or changes in the packing of the constituent atoms. The first order discontinuity is known as M discontinuity. The other is Gutenberg or Worldhorn discontinuity, which separates the Earth into three zones, namely crust, mantle, and core. The relative volume of the crust is mantle with volume of 82.3% and core with volume of 16.2%. Early in the 20th century, the reality of the Earth crust was demonstrated by a scientist named Mohar Stick. In measurements of seismic waves arriving from an earthquake, those focused lay within 40 km of the surface, seismograph within 800 km of the epicenter, recorded two distinct sets of P and S waves. He concluded that one pair of waves must have traveled from the focus to the station by direct path, whereas the other pair of waves had arrived slightly later because they have been refracted. Evidently, this latter wave had penetrates within that zone and had then been refracted upward to the surface. From this conclusion that a direct compositional boundary strongly influencing seismic waves, which separates the crust from an underlying zone. This boundary is known as M discontinuity. The continental crust consists of two layers separated by a well-defined boundary known as Conard discontinuity. The layers have been defined on the basis of seismic wave velocities and densities. In the upper layers, the velocities of seismic waves correspond to the velocity found by experimental to be characteristic of granite. Hence, they are called granitic or cyclic layer. The layer that is a lower layer corresponds to basalt by its density and seismic velocities and is called basaltic or cymatic substratum. The Earth's crust beneath the ocean consists of low velocity layer of deep sea sediments about 300 to 400 meter thick in Pacific and 600 to 700 meter in Atlantic. The layer of intermediate velocity called basement, about 0.8 kilometer thick, composed of compacted and indurated sediments and lava flows. The third layer is called oceanic layer, which is about 4.1 to 5.8 kilometer thick and certain composition. This three-layered oceanic crust is generally 5 to 8 kilometer thick. From the base of the crust downward to approximately 2,900 kilometer, there is a viscous plastic mass of composition similar to that of Saima. It has been named as mantle and has an average density of 4.53. The central shell of the earth is known as core. They have one third of the total weight of the earth, whereas its diameter is approximately half of the total diameter of the earth. It is believed that its density lies between 10 and 19 to be composed of nickel and iron. It is called barysphere. And the central core have about 3,150 kilometer radius in a liquid state. Temperature of the central core is believed to be 6,000 degrees Celsius. Thank you.